Good day everyone, I'm Jinky O. Pulutan, taking a Bachelor of Science in Agriculture. I will be tackling about what I've learned with the topic I'll going to present in the nature of light and Bohr's theory of all hydrogen atom. Under the group 2, this topic is the 5th lesson from Chemistry 16, section CIJ1. So, let's start. I hope you grasp something from my discussions. Enjoy, have fun. The nature of light. All waves of electromagnetic radiation travel at the same speed through a vacuum but deeper in frequency and therefore wavelength. So, the general equation is C, which is the speed equal V times lambda. V symbolizes frequency coined for the Greek term nu. It is number of cycles per second with the units to the power of -1 or hertz. Then lambda or the wavelength is the distance in one cycle with the unit of nm, which means nanometer, and 10 to the power of -9 meter or angstroms. Then we have the speed. Yes, the speed is, or the C is the speed of light in vacuum with a constant number of 3.00 times 10 to the power of 8 meter per second. That's it, and now let's start to solve this problem. Yes, guys. So, that's it, guys. Sorry for the writing because we have wavelength is equal to 1.00 angstroms and the speed of 3.00 times 10 meter per second. Then we must find the frequency. So let's start sum this. Then let's solve this. Then we have the equation V is equal to C over wavelength. Then C is equal to 3.00 times 10 to the power of 8 meter per second divided by or over is 10 to the power of negative 10. The result is 3 times 10 to the power of 18. So that's it, guys. That's it. We're done. Now let's proceed to the second topic. The second topic is quantum theory and electronic structure of an atoms. Lesson 2, the Bohr's theory of hydrogen. Niels Bohr's, a Danish scientist, explained this line spectrum while developing a model for the atom. The Bohr model shows that the electrons in atom are in orbits of differing energy around the nucleus. Think of planets orbiting around the sun. Bohr used the term energy of an electron is quantized, meaning electrons can have one energy level or another but not between. The Bohr model, early models of the atom had electrons spinning around the nucleus in a random fashion. But as scientists learned more about the atom, they found out that this representation probably was not accurate. Today, two models of atomic structure are used: the Bohr model and the quantum mechanical model. The Bohr model is simple and relatively easy to understand. The quantum mechanical model is used on mathematics and is more difficult to understand. Both, though, are helpful in understanding the atom. Bohr also found that the various energy levels can hold differing numbers of electrons. Energy level A may hold up to 2 electrons. Energy level 2 may hold up to 8 electrons. And so on. The Bohr model worked well for very simple atoms such as hydrogen, which has one electron, but not for more complex atoms, although the Bohr model is still used today, especially in elementary textbooks. A more sophisticated and complex model, the quantum mechanical model, is used much more frequently. So, yes guys, we're done. Now, let's proceed to the second topic. As we can see on the illustration, there is an atom with 3 subshells. Yes, 3 subshells. At the center of an atom, there is a nucleus. Inside the nucleus, it contains proton and neutron. Then, in the first to third subshells, there is an electron orbiting the nucleus. So, that's all, guys. I hope you learned something. Thank you, everyone. God bless. And as all, good lucky. Mwah.